So welcome. Let me make sure. Okay, I guess you're not seeing the presentation again. It's a little weird when I started. Okay, so welcome to this first meetup for us in the Caribbean Tech Dev Slack group. Glad folks can make it. So what I'm going to do today is give a quick introduction to Docker. Now, just a caveat, I'm still learning a bit about Docker myself. And this is going to be what you call a Pecha Kucha inspired presentation. Pecha Kucha is usually a type of presentation for pitches of businesses where, well, I know it from businesses, where you present 20 slides with 20 seconds per slide to kind of give you a presentation time of 6 minutes, 40 seconds. I don't think we can do a technical topic in that short a time. And I also couldn't do it in 20 slides because I didn't have enough time to kind of edit it. So what I did is I kind of brought it down to 40 slides, and I'm still putting the timer on to kind of give me an indicator that I should move on. So let's get straight into what Docker is. And so the challenge is basically this. We have, as developers, a stack of things that we run on. Usually we run a website with some web server stuff running on it. In this case, they have Nginx, and I really need to work on my timing. We'll have a database. We'll have some background stuff. We have a front end, usually HTML, CSS, served up by some sort of nice framework like Ruby on Rails. If you're a really high load website, you might use some sort of caching like Redis. If you're into analytics and logging and doing big data stuff, you might have an analytics data point database. And if you decide that some of these features that are powered in your backend should be exposed to everyone, you may provide an API endpoint. Now, the question as developers when we're building this stack is, do these services and apps interact appropriately with each other? And we keep testing that every time. But as you know, it's like juggling. Every time you add another ball to the group, it's the same technique. You just have to make sure you keep the time in and that you don't drop any ball. And of course, if you pass a juggling chainsaw in there at any point, it gets a little bit more difficult to manage that chainsaw and the balls at the same time. Now, to complexify that, you'll see that as a technical operations person or a server-side person, administrator, you have different sets of hardwares that you want to deploy to. First, there's the development boxes that you work on, which may be your own machine or some development virtual machines that were given. Your QA folks may do some stuff. You may use the cloud, which may be private cloud or public cloud. Or you may open source your product and allow contributors to do it. So, the way apps are, you may move quickly between versions at the very beginning. But the question is, how can I migrate all these as well? Because you may get an upgraded VM, or you may add more processors, more RAM, a different disk size, etc. And you want to be able to migrate smoothly and quickly. So if you find a parallel to test this, they call it the matrix from hell, where you're testing basically every single combination of every single component against every single environment that you have. And you can see that's a lot of testing to keep track of over time. So what they came up with is a situation analogous to what we did in containers, shipping containers, where everybody has different the size of items, packs of stuff. You need to create those across the country. So anything from the size of a car to collection of fridges or items, and we can we found that it was easy to use a standard size thing, which was a shipping container. And just let me check 1 second what that Slack is, because I hope it's not saying that no one is hearing me. Okay, so that's not it. All right. All right, good. So what we came up with is Docker. So Docker is basically the equivalent of those containers that you see on the port for code. So everybody has the same standard size. Everybody knows about stacking containers on top of each other to carry them together. So basically, each component, your static website, to your database, to your queue, to your web front end, fits into a container, and you stack these containers. So Docker is an engine that allows you to take that payload and encapsulate it. So why this is good is that you can then be sure that when you say if my services interact appropriately, that you're pretty sure of that. And what this also allows is that because it's a standard size container, it's the same definition or componentization that's going to be deployed across all the different hardwares. So what this helps to do is it actually helps eliminate the matrix from hell, because instead of having to test for every single component and every single device, let me try and stop this timer from moving. You now have a Docker container that you know is working on your environment, and it's the same container that's going to be running across all the different environments, as well as it's going to be stacked the same way against all the different different components. Why does it work? It's because it makes the developer have stop having to think about infrastructure stuff. So if I'm down a developer, all I need to worry about is what's inside the container. Make sure my codes are put together with my libraries, it's packaged all together and has the data it needs to live. To me, all Linux looks the same. It's just a different container. So for the ops person who's actually deploying it, they're actually not worried about what's inside. They're just worried about what's outside. How much resources is this thing going to consume? Is it going to work well? Is it going to constrain resources? And to them, it's okay, because they just know that this container is doing the same thing as every other container. It's going to log stuff. You're going to be able to get remote access to it. You can stop, or copy, or move it across the new host with more resources if one container host becomes overloaded, and that makes life wonderful for all of them. So we're used to virtual machines, most of us, I hope, where virtual machines are basically uses a hypervisor technology to create an instance of an OS in a guest OS, and then you layer your app and libraries on top of it. So containers are what you call a little bit lightweight. They're isolated. They share the operating system, but at some level, but they have their binaries and applications run in a separate space from the host operating system across different containers. The reason it's called lightweight is that instead of in a VM where you have every single copy of the every single component has a copy of the OS, inside of a container you actually don't have that sort of situation, because you only have the original app, which has some binaries and a library, and you make a copy of the app, and then you basically layer that on top of a shared system. So the basics of Docker basically are this: you have a container which you're built using something called a Docker file, which defines what's the dimensions for this container, what software should be running on it, what applications should be started. It doesn't define hardware, but it just defines what the application is. So from that, you know that this running on your host OS is fine. So you build that out and you get a container. You publish it to what you call a container repository. So it's just like a GitHub. GitHub is a repository for your source code. You can also put Docker image files into a repository called into an image repository registry. And this registry, there's a free one called Docker Hub, which Docker runs, but it doesn't restrict you to just using that registry. It's just the one that the Docker command line tool knows out of the box. Now, once you have that image in the repository, other people can pull this image and deploy the same exact app that you've published, defined in the Docker file, into their own environment, and they can be guaranteed it will run the same way it runs in your environment. Right? And that's pretty cool. And you'll see some terms here where you build a Docker file to develop a container, you push the Docker container to a image registry. People will search for your image and then pull that image into their own host and then run it. So how does this work for updates? Because you're changing your code, so that means your code will change over time, and therefore your image itself will also change. So what would happen is you make changes to your base container, you push it to the image registry, you apply the update, and then the person who's running a Docker image is actually going to have that copy running right away. Now, the next time you do an update and push it to the image registry, the person who's running the application container on their end just has to run Docker update, and it will then check the registry, compare it to the version that you're running, and then upgrade it accordingly. It won't do a full update; it'll just get a differential or diffs. So it's pretty cool. It's just like GitHub in a sense. So Docker has become one of the most popular containers out there because it really has a really wide operating system support, ecosystem support, including its basis on the Linux 2.6.32 plus kernel. There's a small purpose-built Linux called Core OS that is at the heart of a Docker container, and then there's a ton of different people who work with it to help add on value to this, including folks like OpenStack. Microsoft also has a deployment of Docker available for its Linux VMs. So how does this help a developer? And excuse me 1 second while I just check the text, the Slack, to make sure there's no questions. So do I get a general? Okay. Just let me do a quick check to the. All right, so I have 6 viewers. So Horace joined the group chat then. All right, can everyone still see me, hear me, etc.? I'll trust you to be my sounding board for this. If you can't hear me, or if I drop, just put a message in the chat we had going, because I'm not too familiar with the Google Hangout. So turning back to the presentation. So how does this work for developers? So developers normally work locally. So we work in our own environment. It's on my laptop. I'm writing code, whatever. But what I also have now is something called a Docker file. The Docker file is deploying an image for me for a container, and my code runs inside that container. And I can test it and make sure it runs really, really well. So what I do then is I would actually check my code into Git like I normally do. And hopefully you'll have some sort of automated build process, which will say, okay, my Git will build against the same Docker file that I'm using locally to produce the image that will then run on my container environment, which is in the cloud, which is my real deployed application. So what this does is it actually allows you to get some sort of really good continuous integration and stuff going, where you're using something called DevOps, where the developer, you can push releases a lot faster because your code is now synchronized inside your container and it's running. So if it's running and it passes all tests, it's the same image that's running in the cloud on a production environment, so you can pass that along. So how do you get started? So to get started, originally you had to install VirtualBox and then install Docker using the installation file. There's actually this new cool set of tools called Docker Toolbox, which Docker released. What it does is it includes the Docker client, which is the command line tool. So Docker machine, which is the host environment for the Dockers. A component called Compose, which says, okay, well, if I have a web container and a database container and maybe some sort of data processing container or login container, and I want those all to, when I'm creating an instance of my application, that this is what my application is. Compose lets you generate a file or use a generated file to say, okay, this is how my application is defined, and this is how they should talk to each other. Kitematic is a visual or GUI-based tool to do what Docker command line tools does. I'm not totally familiar with it. Maybe if you're more familiar with the GUI, you're more comfortable with it. But I always prefer to learn the command line first, so that when I'm using a GUI, I can kind of get a little bit more under the hood in terms of understanding what I'm doing. And of course, with the toolbox, you get VirtualBox right away. VirtualBox is your hypervisor technology, because you do have one, in essence, virtual machine underneath it all for your local machine. If you're using Macs, you can use Homebrew to install Docker directly. And if you're using Windows, you have to enable Hyper-V before you can start. Oh, sorry, not Hyper-V. Hypervisor threading. That's a little bit misleading. So you don't actually need Microsoft's Hyper-V. You just need to enable hypervisor threading on your machine. So when you're getting started, the first thing you should really do is understand the architecture and then do a quick smoke test, which I'll show you now. So this is how it works in terms of the architecture. There is a host that's running Linux, and then there is a Docker client, which is a command line interface to all the different containers. And there are daemons running each container to make sure that everyone's running fine. If you're on Windows, then what you're basically doing is you're drawing a Linux VM on top of, and then the daemon runs inside of there. It still runs inside of Windows as opposed to inside of Linux. And let's turn off Slack for a second. Okay, great. Oh, great. I'm hearing. Okay, good. I'm glad everyone is hearing. Okay. So how would I smoke test the environment? And I will take the feedback that I won't be using this Petra Kucha for a technical presentation again because it keeps flipping my slides every 20 seconds. So the first thing you'll do after you install the Docker tools is, let me get out of this. You'll still be seeing me. So we're going to get into some typing now. So I'm going to run the Docker quick start to the terminal, which is installed when I install the toolbox. And as you can see, I shut down my machine just now to let it start back up. So it's going to start up a little bit. So that's going to take about a minute. So while I'm doing that, I'll tell you what this command is going to do. So Docker info will actually just show me what's the status of my environment at the moment. So Docker is the main command line tool that you'll be running for managing containers. Docker machine, Docker-machine will be the command that you run to manage the host. So just like I said, there's a host which is running the different clients and daemons. So Docker containers used to manage these things in Docker host, and Docker is used to manage these things inside the client. I'm sorry, I'm talking too fast. Yeah, I guess that's part of me just trying to get through all the content because I know 40 slides can be a little daunting. I don't want folks to fall asleep. All right, so let me check this command line. So I have, okay, so you can see here Docker is configured. You can see it's set with this nice little IP, 192.168.199.800. If I ever forget what it is, I can just say Docker IP default. Oh, sorry, Docker machine IP default. And it'll tell me what it is. But right now, I just want to know what's going on in Docker, what containers I have running. You can see there's a lot of info coming up. So right now I have 6 containers running with 58 images, and you can see I'm a pretty busy guy with Docker. What's the version of the server I'm running, what logging, etc. You know, what's the operating system that it's using to manage all these Docker images. So that's a lot of stuff. But this one here is what you really want to look at. Provider equal VirtualBox, and right now Docker uses VirtualBox by default for all its container hosting. For its host containers. So in future, what you'll find is actually right now I can actually switch this across and use Parallels if I wanted, which is Parallels Desktop, which is another virtualization technology. I can use VMware to some extent, and soon I'll actually be able to use Windows as well, which is kind of cool. The next version of Windows Server should support Docker as well. So so that's pretty cool. So I just did a smoke test, so I know my environment is working. The next thing I want to do is run something called Docker PS. What Docker PS does is it tells me, just like with your system, so when you type PS, it tells you what's running on your system. Docker PS tells me what containers I have running exactly on this system at this moment. And as you can see right now, I have nothing running. So that's kind of cool. But if I ran Docker PS-A, -A tells me all these the Docker containers I had running at one point. So they have stopped, but they're not destroyed. So they're still around. I exited those containers. I have a few that I was running in the past, and this is pretty cool when you want to restart or reconnect a container that you exited from, but you don't want to have to recreate the entire container. So now that I've done the smoke test, let's do something cool. I want to run CentOS, which is a variant of Linux, on my system. So as I said, Docker is already tied to a registry from Docker Hub um, by default with the command line. So I can just type Docker pull CentOS :7. Now this command just says, okay, I'm going to pull an image from the registry. The name of the image is called CentOS, and the version of the operating system is after the colon, or the name. What is called as a tag. So you can have a tag, tag, where the first tag is the name of the image, and the second tag is the version of it. So I can have CentOS 6, CentOS 7, or if I want to, get the latest and greatest, usually there's a standard that people say latest. But best practices always say when I'm looking for an image, I kind of want to be explicit. So, it's sort of like, SQL where you say select star. You don't want to do that. You want to know exactly what you're getting back. So I want to get CentOS 7. So when I type that in, what it's going to go is going to go to the image registry. Is going to find, well, apparently I didn't download it before, but it's going to find the version of CentOS that I want. And then you see it's pulling a few things right now. And while it's pulling that, let me go back to the presentation and kind of explain what's happening there. So Docker works in this format of a base image and then diffs on top of that image. So, if the kernel is the Docker container, there's a base image somewhere, and then there's several diffs on top of that that make up the definition of what CentOS 7 is. So this base image, well, if this was Ubuntu, this would probably be Debian, and then the add-ons that make Ubuntu, because Ubuntu Linux is a Debian-based distro. But you can see as well that it's adding programs on top of it. So if I require, for example, Emacs or Apache to run my website, I can add on the diffs on top of that. So what that means is that when one of these base images below gets updated, I just have to pull the diff for that and then recompose my image. So in a sense, what's happening right now is I said Docker pull. The daemon said, okay, I want to get CentOS. Let me reach out to the registry and see where CentOS is. And I get that, so I'm going to make a copy of that here. And then I'm going to apply that to one of my containers. I'm going to create a container that's running this image when I run Docker run afterwards. Okay. So let's see if so you can see now it's pulled the CentOS 7 images, and if I type Docker images, you can see here this line that CentOS is now been pulled into my my list of available images. That's pretty cool. So yeah, I just kind of stepped and I said, okay, Docker images. Now Docker images just shows the final images that are available. If I type Docker images -a, what it'll do is it'll give me a list more than that, because there's a series of intermediary containers that are pulled as well, and that composes all these little diff versions that you saw when I ran the pull. Where is it? Here. Yeah, when I ran all these things here. So these are the different things that make up CentOS. So if I go further down and I look and I see CentOS. Oof. Yeah, CentOS 7. And then you'll see somewhere in here that the same code, yeah, here it is. You see these things make up CentOS 7. Same set of identifying image IDs. So that's a lot. I know it's getting a little complex, so I don't want to get too much into the weeds of it. But let's do something cool with container. I pulled CentOS, so I want to run an application now inside of CentOS. So okay, so I see we have a few other folks joining. So what was the command again? Docker run. So yeah, let me just copy this so I don't make a mistake. You can see what I have here. Docker run runs the container that I pulled. So I'm running CentOS 7, and then afterwards, what I can do is I can pipe in commands. So if I know the system is configured with a certain application, I could just issue the startup of the application command. So in this case, I just want to echo hello world. --rm, all this does is it says, okay, when I'm finished with executing the application, remove the container. So it helps keep space saved, because again, each one of these containers is going to take up a little bit of space. So that's pretty cool, because I got to say hello world. So, I mean, what's so special about that? So let's do something a little bit more. So let's run a bash shell. Bash is a shell interface. So let's run. You can see I have now what looks like a Linux command line interface. So what's so special about that too, you may ask? Well, let's look at that same PS command, but let me look at this is my other bash window. So if I type PS, you see these are all my applications running on my OS X right now from this command line, which is bash, because you can see it says bash here. But if I type PS here, what is it saying? It's just 2. So what is this telling me is this bash command is actually only running inside an environment where it's isolated. So that's pretty cool, because what that means is if it's isolated, I can let it do some stuff, and it can even do crazy stuff, and I don't have to worry about it interfering with my host operating system. And that's pretty cool, especially when you're doing things that involve exposing your application to the internet of everybody. So the other thing that's cool is the container itself is forgiving. So let's see. Yeah, so this command. Yeah, so you can see here that this is telling me that this is actually an OS that's CentOS as opposed to regular to my regular Linux. But what I want to do is I want to do something a little bit dangerous. So let's say I wanted to remove this. Now, anything that you said, I wouldn't recommend running this on your main Linux system. What I just did there is I removed the ls command. So if I rm-rf/user, so that's gone. I shouldn't have a something I did wrong. Got to remove the second set, so I want it to be even more dangerous. So I move my S-bin. You can see I have no ls. So what did I do? Did I just mess up my container? Actually, no, I didn't. Because I instantiated a copy of the image, I didn't mess up the image. The image generates a container every time I want. So if I exit this, I'm back to my regular command line, and I run docker run again with the same command bash, I type ls, I get it back. So that's pretty cool, because what it does is it allows you to experiment and try stuff without messing up your main image if you know you have an image that's, your start of everything. So that's pretty cool. So let's do something a little bit, more advanced. So everyone here, I'm assuming, is familiar with Tomcat. So thankfully, the folks at Docker have created a container for Tomcat. And if you're ever worried about if there is a Docker, I think it's Docker or images, just write, not Docker search. Actually, the way I would normally do it is I would actually just go to a new browser window, and let me see. You can hear me go on. Great. I would go to Docker Hub, is where it pulls, and I would search for whatever I'm looking for. So if I wanted to look for a MySQL container, I can see here, there's an official one, and this tells you how many people have rated it and how many pulls have happened. And I can see, okay, well, this is what, this is the description of it, and this is the command to pull it. So I can get a MySQL running right away. And that's pretty cool, because a lot of these major vendors have actually started creating containers for it. So in all case, what I want to do is I actually want to just create a Java. I want to start running a new Java servlet. So I want to run Tomcat. And I'm not a Java expert, but I just find Tomcat is. Ooh, oh, this is why it's not working. I'm still in the. Right. So if I run Docker search, Tomcat, it'll actually search my image registry in Docker Hub and tell me what's there. So I know there's a Tomcat here, and then there's also Tomcat version 8. So let me pull specifically Tomcat. So you see here, what I did is I ran the Tomcat 8 directly. I didn't pull it first. And because I haven't had a copy of it, Docker knows, okay, I need to pull this from the registry before I can actually run the image. So what it's doing here is it's actually going out and pulling down all the base images for Tomcat 8, which I think is running on top of CentOS as well. So that's why it downloaded a few things really quickly. And it will start to run Tomcat for me. So while I was running, let's just kind of see what's going to happen. Let's see what this command is actually doing. So, and I ran docker run. The -rm tells us we want to remove the container when it's done running. The -p with the ports tells us, okay, we want to map the containers port 8080 because it is in a virtual environment to my host port 8888, which is the local host. So the condition should be that, if I go to localhost 8888 when this is finished, and yeah, I see all is running, I should get a Docker. I should get the Tomcat management interface. So let's do that. Oops, nothing happened. Why is that? Well, we kind of missed one step. Remember, your Docker host is actually mapped properly, but it's on Windows and Mac OS, or in my case, Mac OS X. And we didn't expose those ports to it. So what we have to do is we actually have to go into the container management program, which is VirtualBox, and enable the port forwarding for this. So think of it this way. I have a client running, and I have a Docker host running Tomcat on port 8080 and exposing it. Let me increase this font a little bit. Yeah, and the host knows to expose port 8888, but the client, the host environment, which is Mac OS X, doesn't know that, or doesn't give you access to that yet. So what I do is I need to actually let the port be opened from the container virtualization environment to my client. And how I do that is I go into and this is one time you'll probably have to do it. I'll actually have to go into VirtualBox. 8888, yeah. So I would see here there's a default running, which is my my Docker host container. Go into my network, click on port forwarding, and I think I should change this to my host is 8080, and I want it to be 8888. That should be okay. That should be okay. And if I go to now, I should have. Oh, what did I do wrong? Guess IP. Oh, I think I have it switched around the wrong way. It should be. Not one. Should be 8888. 8888. Okay. 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 So I missed something somewhere. But no worries, because I actually know is for this guy. What you did wrong was your host is Mac just now, Linux. Yeah, I think something was wrong. But what I'm doing is I'm just going to quickly test, make sure that 8888. Right, okay, I know what you mean. So this needs to be set. Where's VirtualBox? Network, port forwarding, 8888. Okay. Right. So if I type localhost, right? Yeah. So you're correct. Let's see who typed that. Dario Thornhill. Yes. So you were very correct, and I blame this on my sleepiness and and old age. So you can see here I have a Tomcat container running. So if you look at the service status, I don't have any credentials. So I'm not sure about how to use this yet because I'm still very unfamiliar with Tomcat, or it's been several years. But it's pretty cool because I actually have a Tomcat container running. And you can see in here that it got a hit somewhere. It should have reported it somewhere here that there was a hit to the main Tomcat site. So PowerPoint. So we have a running container. So let's so let's take a closer look at what's going on here. So I'm going to run another Docker quick start terminal. I'm going to type Docker PS. And you remember before when I ran it, there was nothing running, but because I have Tomcat running now, it's telling me what is running. And you can see this name here. It's a shortcut way of referring to it. I found a lot of modern apps, they tend to take like two words and they put them together with underscore to kind of give a unique name in. You can actually set this name by using the, I think, -- name when you run the command to name it whatever you want, so you don't have quite such a random naming happening. But the names can get pretty amusing at times. So I still have it, haven't built that habit. So suppose I wanted to interact with this container now that it's running. I mean, I already ran Docker run, so can I get into it? Well, yeah, you can, because what you can do is you can actually run something called the docker exec command. Oops. So I run docker exec, which says execute this command. The I and T, I forget what they stand for individually, but it means to make it an interactive session. So don't just run the command and exit. Run the command and let me interact with the shell of the interface. The name of the container is tiny_Hawken, and the command I run is bash. So I want to get to a bash command. And you can see here I'm at a bash, and if I run yes, it's running. It's inside the container environment. So if I look a little bit more deeper into here, you can see my PWD, which I'm working. I'm actually inside the Tomcat folder, and you can see inside here that I have all the different things that you'd expect. So you have your web apps, which includes the host manager, which is running right now, and the manager. So you can actually run, if you had a Docker file, which is what is used to compose it, you can actually drop your source code directly into the Docker container and then run Tomcat, and it would load it up right away. So let's exit from this now. So let's exit here and close that one, and let's close Apache. If I run Docker PS, have any containers running again. Why is that? Because remember when I originally ran it, I ran it with -rm, which meant remove the container after I'm done with it. So therefore Docker PS should say, okay, I have no container running. So these are some of the extensions you can use with Docker run flags. You can give it a name by using double dash name. So instead of tiny underscore Hawkins, I could have called it my Tomcat server and be able to use that. Dash D runs your container in what you call daemon mode, which means in the background. You can set it DNS. Dash IT means to give it interactive, so it would give you that ability to be at the command line. So you wouldn't use this with dash D because dash D means run in background and dash IT means run it in an interactive mode. You can pass variables. The dash uppercase P says, okay, any ports that this container is exposing in the container environment, expose on the host. So you'll still have to do a mapping to get the local host colon whatever the port is but the host itself, if you can reference it by the IP. There's some more advanced ones like dash dash link and dash dash volume. I won't go into those now, but basically dash dash volume lets you attach to a secondary file system attached to it. So, and dash dash link lets you link multiple containers so that they can see each other. So, right. So there were other ways if we didn't run. So if we ran the container again in daemon mode, what would this do? So the last time I ran without daemon mode. So I had to control C to break out of it. But if I just run it like this, you see it just tells me, okay, it started. And if I do docker ps, you see it's running. So it's not as easy to just break out of it and stop and destroy the container. What I'd actually have to do is I'd actually have to name it. So let's just look at that command again. I named it Tomcat 8 and I expose the ports. So if I want to docker stop, I would say docker stop Tomcat 8. And what I'll do is it'll shut down the running container. So if I do again, there's no image running. So the thing is, if I do docker ps-a, it's still there here, and it is consuming this space at the very least. And if you're like me, you're probably not running much memory, or you find yourself running out of space. You want to probably get rid of these containers. So what I'll do is I'll docker rm, and I'll put the name of the container, and that will actually remove it from the list of containers that I have stored locally. What that means is that if I start running enough one, it'll take a little bit longer to start back up. Or if I say docker start, it won't know what I'm talking to anymore because it's not in the background. So I have to rerun. I have to re-engage a running container to get it going. And that's kind of it for me. Not exactly. Where the next step would be is, after you get the Docker toolbox, create a Docker Hub account so you can start, pushing these Docker images that you're creating for yourself somewhere, so you can pull them back later. You can learn more .docker file, which lets you create your own Docker images. And I put 2 links here that give you links to the syntax for it, which I won't go into. I can do a separate session where we actually go into building our own Docker file and then talk about the best practices. You can look at my own Docker files, which are very basic at the moment because, again, I'm still learning. And I also put all my work on GitHub. When I create a container and I find it's useful and I'm going to always use it, you're going to find it in my GitHub repository, my public GitHub repository. And again, if you find it useful and you want to fork it and contribute and send back a pull request, I'm always very open to that, the contribute and give back concept. They're all, Apache license or whatever the default GitHub license is. And to give credit where credit is due, this presentation is extremely heavily based on 2 other presentations which are extremely good. One is the Red Hat Workshops, Intro to Docker and Kubernetes. And the guy there does an excellent job. Many of the slides came from there. And also SlideShare has an introduction to Docker by the Docker folks, which I relied on for the very beginning of this presentation in a very large manner. So giving all credit where credit is due, this is really a mashup of those 2 presentations made to fit within the time of this presentation. So now I am done. We have some time for some questions. And you can feel free to turn on your mic. I'm going to turn off the screen share now. Or to use the chat that's available. Stop. Voice is always good because, at least I know I'm not alone in the world here. If you're on the Slack, I have the Slack. I reopened the Slack so I can see what you type in there as well. So, and thank you, Joanna, in the Docker channel on our Slack group. She posted links to the Docker Toolbox and Kittymatic, which is the GUI interface for the Docker command line. So, Joanna, if you're on, because I can see the viewers, but I don't know how to see who's the viewers. Okay, so I have a question from Mice. So I can have Jenkins in a container and have that container spin up other containers. I'm looking at a container for every branch on a Git repo. So yes, you can have Jenkins running in a container. I'm not sure what the best practices are, but from my understanding, like Jenkins would be deploying to somewhere else. So I'm not too familiar with how Jenkins works. If it can do multiple builds at a time, depending on some tag or the other. And Ricard has been very kind to help reply to that. Okay, so it seems like Ricard has much more experience. Yes, you would have much more experience than me with Docker containers, wouldn't you? You guys are the ones who kind of introduced me to Docker in the first place. So yeah, I think, let me find that presentation again, that slide. So I think what he's looking at is when I spoke about continuous integration. So he wants to put this Jenkins inside a Docker. And I think it's probably misinterpreted. What I really meant is you are writing a Docker file, which the container server already has knows, but Jenkins is already compiling that Docker file with the new code base that you have to generate a new container. Jenkins itself could run in a container, but I don't think the concept in this was for Jenkins to be in a container itself, merely to manage the container that are being built out. Yeah, so that would probably go into, Dario also seems to have some good experience here. And again, yeah, remember containers are isolated, so you'd have to expose the ports for the Jenkins. Yes, thank you, Joanna. #Docker is the channel that we can put all these questions in. So I hope you guys will also give me some feedback in #feedback in the Slack to let me know how this was. I know it was our first try, so there's been some hiccups. But I hope we can get a little better at this. I hope one of you guys will be willing to present instead on something so that we can kind of share the knowledge that we have in our little growing community that's going on here. So Joanna, I don't know if you have audio or if you're still listening, but unless there's anything else, I will close off the Hangout for now. And I'll give Joanna 30 seconds to reply to that, if I should or should not. Okay, so it looks like we're good to go. So thank you again, guys, for participating and being here. Hopefully next time we'll figure out how to get the audio a little more interactive. Everyone have a good night, and I'll look forward to hearing your comments and feedback on the Slack. Thanks again.